Okay, so now we are going to discuss block number 2, unit number 3, last topic, that is maximum bipartite matching. So let's it's a request for everyone, kindly on your video so that I can take your attendance. Thank you so much. So here we go. We have another topic, that is maximum bipartite matching. You will read this in your graph theory in discrete mathematics. So in this, a matching of a maximum size, that means a maximum number of edges we need, is known as a maximum matching if the addition of any edge make it no longer a matching. For example, here we are. So this is a bipartite graph on the left hand side, and here is a maximum bipartite graph matching. That means we need a particular graph that a particular node is not taking more than one time. So the maximum bipartite matching problem can be solved by transforming the problem into a flow network. So here it is. We have a bipartite graph. Here is a flow network, and here is a corresponding final flow network. So how to construct a flow network? Flow network always represent by dash. D dash is equals to 4 dash comma E dash. That means we have to add additional source node and a sink node to the bipartite graph. So here we added the additional node, starting node S, and the final node, and connect each and every node with this. Right? After that, the capacity of every new edge is marked as 1. So we have to mark 1, 1, 1, 1, 1, 1, 1 fit on each and every edge. Right? After that, we have to find the maximum flow. How you can find a maximum flow? By Ford-Flokson algorithm. Right? In this, you can apply BFS to pick a path with minimum number of edges. Right? So so this graph computes a maximum flow in a network by applying the greedy method to the augmenting path approach used to prove a maximum flow. So we can add, it's not compulsory to take these edges only. You can take the opposite also, but you have to specify to select the edges with minimum number. Now, the next topic that we are going to discuss today is dynamic programming. This is totally opposite to greedy technique. Greedy technique gives a optimal solution in some cases, but dynamic programming always gives you a optimal solution. So in this, we will discuss principle of optimality, matrix multiplication, matrix chain multiplication, optimal binary search tree, binomial coefficient computation. So we'll start with principle of optimality. So dynamic approach is an optimal technique. That means it always gives us a optimal solution. That means maximum profit. So optimization problem are those which requires either minimum result or a maximum result. Right? So we can say let's take one example. If we want to find the profit, we'll always find out the maximum profit. And if we want to find out the cost, we'll always find out the minimum cost. That means both greedy and dynamic are used to solve the optimization problem, but their approach to finding the optimal solution is totally different. right? In a greedy method, we always try to follow the defined procedure. For example, Kruskal. Using a Kruskal, we are finding MCS-211. That means minimum cost spanning tree. Always select edge with minimum weight, and that gives us a best result. Right? So this is the example. Or if we are talking about a dynamic programming approach, so it is different and time consuming compared to a greedy method. So dynamic programming granted to find the optimal solution of any problem if their solution exists. So mostly in a dynamic programming, we solve a problem using a recursive formulas. So this is the difference between the dynamic and the greedy approach. Now the next one is principle of optimality. So dynamic programming always follow principle of optimality. Right? So if the problem have an optimal structure, then definitely it has principle of optimality. So principle of optimality shows that a problem can be solved by taking a sequence of decision to solve the optimization problem. So it will give you a maximum or a minimum solution. So we have to follow these major steps to solve the to use the dynamic programming. The first, develop a mathematic notations that can express any solution. So in this unit, you will get a lot of mathematics equation. After that, prove that the principle of optimality hold. Then develop a recurrence relation that relates a solution to its subproblem using mathematic notation. And after that, write an algorithm to compute the recurrence relation. With the first 2.3 topic, this is a matrix multiplication. So we all know that how to solve a matrix. There is one concept, that means there is a procedure. If the first matrix number of column is equals to second matrix number of rows, then we can say both matrices we can multiply. So here is P into Q and S into T. If Q is equals to S, so we can multiply the matrices and we will get P into T as a matrix. Now, here is a challenge. If we are solving a matrix multiplication, we always get a complexity. So what will be the complexity if we are doing a simple matrix multiplication? What will be the complexity?
N square.
N square. Okay. Any other? We already discussed in previous classes. I know you all are tired today. You are taking class from 9 a.m. Please answer the question. What is the complexity if we are multiplying two matrices or a two matrix?
Log n.
Log n. One answer is log n, one answer is n square. Another one? N square. Okay. Any other? If we want to multiply two matrices, we have A matrix and B matrix, right? So we have to use two loops, one for row and one for column. For again, we are putting multiplication into third matrix. Then we have to add one more loop. That means the complexity of multiplication of two matrix is equals to n cubed. Yes. Here we have another matrix chain multiplication. This is a dynamic matrix approach, dynamic programming approach. It is a very, very important question. I got this question in my PhD entrance exam. So I have to solve the complete matrix chain multiplication algorithm. I have to write this complete algorithm using a dynamic programming. So here we have some dimension. We don't have a matrix elements. We have a dimension of a matrix. So what do you mean by dimensions of a matrix?
X, X, Y, Z axis. If it's two dimension, then it has two X axis and Y axis, and it's three means number of array.
Yes, number of rows and number of columns. If I am talking about 2 into 3 dimension, that means number of rows is 2 and the number of column is 3. So here we have A1, A2, A3 and A4. This is a chain of matrix. So if I want to multiply this matrix, we have so many approaches. Firstly, I can multiply A and 4, then multiply the answer with 2. After that, I can multiply the answer with A1. The next approach is I can multiply A1 and A2. I can multiply A1 and A3, then multiply both. I can also do A1 multiply by A2, then I can multiply with A3 and I can multiply with A4. So these are so many approaches we have. So that's why this is known as a chain of matrix. So whenever we are multiplying, it's all every time give an impact on the cost of evaluating the product. Right? So for this, we have a dynamic programming method to determine how to optimally parameterize a matrix chain. So we have some steps for that. The first step is the structure of an optimal parameter. So we have find the structure of an optimal solution, then recursively define the value, then compute the value, and in the last construct an optimal solution from computed information. So first one is structure of an optimal parameter. That means we have to, parenthesis, we have to define which approach we are using. We are using this approach, we are using this approach, or we are using this approach. Then we have to find a recursive solution. How we can find the recursive solution? If we are working on a matrix chain multiplication problem, we have to pick the sub-problems first. Right? We always have AI plus 1 to AJ dimensions matrix. For example, A1, A2, A3, A4 and so on. I value is always greater than and equals to 1 and j value is always greater than and equals to j and n value is less than and equals to j. So if I have a matrix value I comma j with the minimum number of scalar multiplication needs to compute the matrix. For that we have one formula like this. We will implement with one example. So let's take example first and then back to the steps. So here, find an optimal parenthesis of a matrix chain product whose sequence of dimension is this. So A1 is a matrix with the dimension 30 into 35. A2 is a matrices with the dimension 35 into 15. A3 is the matrices with dimension 15 into 5 and so on. So the first is MII is equals to J. That means when I is equals to J, then you have to put 0 in that place. So we have a matrix and here it is 1, 2, 3, 4, 5. So, and this is, you can write a I here 1, 2, 3, 4, 5. When I is equals to 0, you have I is equals to J, you have to put 0 there. So this is 1 and this is 1, here is 0. This is 2, this is 2, here is 0. This is 3, this is 3, 0. This is 4, this is 4, this is 5, this is 5. All these terms are 0. Till now, any problem? Because I completed my first step. First step is whenever you have mi comma I, that means I is equals to J, at that place we have to put 0. Now, second step. The optimal solution of AI multiplied by AG. So if I am taking A1 into A2, we have to must break at some point K. So K is always less than J and K is greater than and equals to I. And also put some parameters. Parameters should be Pi minus 1 multiplied by Pk multiplied by Pj. So whenever you are computing Mij, you use this formula. The formula is Mik plus Mk plus 1j plus Pi minus 1 Pk Pj. So let's do this one. So this is my second iteration. So I is equals to 2 here. So we have to implement first. We already computed M11. So the M11 value is 0. Now I am going to compute I value here is 1 and J value is 2. So M12 I have to find. Right? If we are talking about a K, here is my values. So if I am going to Mij, I value is 1 and J value is 2 there. So what I have to compute, I value is 1. What will be the value of K? K is equals to J minus 1. So here we will write 2 minus 1, 1. This is 1 plus 1, 2. And this is also 2. So here it is. M12 is equals to M11, M22 plus the value of P. How we can calculate the value of P? I minus 1, K and J. I minus 1. The value of I here is 1. 1 minus 1, 0. The value of K is 1 and the value of J is 2. Okay. Now we have to compute M12. So we have to put the value of M11. M11 is 0. So here is 0. M22. M22 value is also 0. So here is 0. then I have to put the dimensions value, right? So when I am working on this, this is P0, this is P1, and this is P2. So P0 value is 30, P1 value is 35, and P2 value is 15. So we put it here 30 into 35 into 15. We got our answer 15,750. Any question?
No, ma'am.
Now the next one is we have to compute 2, 3. That means I2 and then the value of j is 3. That means we have to compute here I comma k. So the value of I is 2 and the value of k is j minus 1. J minus 1, that means 3 minus 1. So here it is. The next formula is m k plus 1 comma j. K value is 2, 2 plus 1 is 3 and the j value is 3. Now we have to compute Pi minus 1, Pk and Pj. Pi minus 1, that means 2 minus 1 is 1. If we are computing P2, that means this is a value of Pk, then Pj. Put the value and compute it. You will get the solution of this 2, 3.
Ma'am, what is K
Similarly
here?
with, sorry.
Ma'am. What is K here?
Okay, this is the value of I and j, right? And the k is always equals to j minus 1. That means 3 minus 1, 2.
Okay. So how we calculate value of K?
J minus 1.
Okay.
So here is the value of j, that is 3. 3 minus 1 is 2.
Okay, right, ma'am. Thank you.
You can do this. Is it clear for I is equals to 2? That means step 1. Can I proceed?
Yes, ma'am.
Now the next one is I is equals to 3. For that case, you have to find the minimum value. Here is no difference between both the values I and j. Only you have to, there is a difference, only one difference. 5 minus 4, 1. 4 minus 3, 1. But here 3 minus 1 is 2. That means you will get two value and then you have to take the minimum value from that two matrices value. So here M1, 3. That means here you have to find M11 plus M23. That means here you find K and J. And for the next, you have to find K plus 1 and J. Right? Do remember this step. If there is a difference between 2, 3 minus 1 is 2. That means you have to find M11, comma, M23, comma, you will get the similar value here. After that, the difference is 2. Then you have to find the matrix also with the value 2. That means index value 2. after computing this, you have to find the minimum value from both. If you have a question, you can ask.
Again, here I am confusing with value of k.
The value of k, if we are talking about for the first, it is giving us j minus 1 is always equals to k when there is a adjacent matrix.
And in this case, where I is equal to 1 and j is 3.
That means we have to break this matrix. Right? So if we are talking about the dimensions, so here we have to find first 1 comma 1. That means I comma I, and here we are computing I is equals to I plus 1. Here is M2 comma 3. And here is both the values remain same. See. This is a value for the I is equals to 1. You have to compute using this, where the k is always equals to j minus 1. Right? After that, you have to compute the optimal solution for the next dimensions also. So here it is. This is 3 and this is, this is 3 and this is 1. You have to compute this value also. That means you need 1 or 2 to compute the 3, right? So for that, you have to implement M11, then M23, and then P0123. That means here you are putting I, right? This is I plus 1 and j.
Okay.
For the next, here is I plus 1, and here is jj. Here I is constant and here jj is constant. Then put the values and you will get all the matrices detailed here. Now here you have 1 and 4. That means 3 value you got here, and after that you have to take the minimum value. So first one here is this, second one here is this, and the third one here is this. Similarly, for 1, 5, you are doing the same. Okay, if we are talking about 1, comma 3, 1, 3, that means A1 into A2 into A3. We are doing for A1 into A2. If we are doing A1 into A2, the dimension of A1 into A2 is 30 multiplied by 35 multiplied by 15. Right? So this is 30 multiplied by 35 multiplied by 15. But if we are talking about A1, A2 and A3, so here we get 30 multiplied by 15 multiplied by 5. 30 multiplied by 15 multiplied by 5. After that, you have to multiply 1 and 4, 2 and 4, 3 and 4. And in the last, you have to multiply these things. Yes, question please. No questions.
No, ma'am.
Next is optimal binary search tree. Optimal binary search tree matlab that is giving me a optimal solution. That means it will take a minimum time. Right? So if we are talking about a binary tree, so how we calculate the binary tree? How we can draw a binary tree? MCA, MCA first. You all are here. Kindly acknowledge.
Yes, ma'am.
Ma'am, we are here. Yes, ma'am.
I think you all are sleeping.
No, ma'am, we are here.
So how we can create a binary tree? What is the formula to draw a binary tree? A binary tree is a binary search tree that all the keys smaller than root are on left side, and all the keys greater than root is always present in the right side.
Yes, ma'am. Yes.
Right? So here is 40. 20 is less than 40, so you have to place it on left hand side. 10 is less than 20, so it will be placed on left hand side. 30 is smaller than 40, so it will replace on left side. 30 is greater than 20, it will be replaced on right side.
Okay, got it.
So here is a key that is 10, 20 and 30. We have to place it. So how many binary search tree is possible with these keys? So this is a formula. You have to compute using this formula and you will get the answer. So here is the root. I took a root value 30 here. So this is 30. Then left 20 is less than 30. It is in left hand side. 10 is less than 20. So it is in left hand side. Right?
Yes, ma'am.
Yes, ma'am.
If here is a mistake. So if we are taking 2 as a root, so we can take 10 in the left side and here it is right hand side. So here is 10, this is the right and this is left. Here is 10, again here is mistake. So kindly ignore V and E. It should be a different way. So here is binary search tree where we have the child element as a search key and the other element is roots. And we written this in a tabular form. we have to use a dynamic approach, programming approach, and using this approach, we have to find the optimal binary search tree. So we have to find the optimal binary search tree for n is equals to 4. We have 4 keys here, having successful search and unsuccessful search. We have two rows here, pi and qi. That means whenever we are using this key, there is a 3 implementation. So first we have to find w. W, that means when both are equal, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. When both are equals, we are giving a value q0, q1, q2, q3 and q4. After that, we have to find the cost, that is E. How we can find E? Before going to find E, we have to calculate the values. So here is W00 calculated. I have to perform W01. How we can perform W01? Formula of W. Here it is. You have to find Wij is equals to W I comma j minus 1, pj and qj. J is always with the dimension, that is p and q. Here it is I and the next one is j minus 1. J value is 1. 1 minus 1, 0. And this is always pj and qj, p1 and q1. For w12, I is 1 and j is j minus 1. So this is 2 minus 1 is 1. This is p2 and q2. So on with the w34. Now we have to calculate. We have to calculate the values. So what is the value of W00? W00 value is equals to Q0. So Q0 value is 2 here. So here is 2. Now we have to add P1 and Q1. That means 3 plus 3, 8. What is the value of W11? W11 is equals to Q1, that is 3. So here it is 3. 3 plus P2 Q2. This is 3 plus 1. So it is 7. We have to compute this till 3, 4. So when we compute this, we have another formula. We have to calculate E. That means a cost. So initial cost when all the I and j are equal will be 0. So here E01. How we can compute E? Here is a formula. So we have to always compute I plus 1. I is 0 and I plus 1. So here we have to find the minimum. Here I comma I plus 1 comma j, and then here is the value of Wij plus 1, ij. So Wij, I value is 0, j value is 1 here. This is I plus 1 comma j and this is I comma j minus 1. After calculating all the values, you have to pick the minimum value. Minimum value is 8 here. You have to compute 3 comma 4, E 3 comma 4. Now you have E values, W values. You have to write in a row and column format. So this is row 0 and 1 when I is equals to 0, and this is 1, 2, 3, 4. So with first, here is 0, that means W00, E00, R00. This is the value of W00. W00 is Q0. Q0 value is 2. We have to put that value here. This is 2. E000 and R00 also 0. Then we have to find first. That means W11, E11, R11. So for that W11, we calculated W11, that is equals to Q1. The value of Q1 is 3. So we put it here. E11 is also equals to 0. R11 is always equals to 0. After that, the next one is, this is 0 and this is 1. This is 1 and this is 2, and so on. You have to calculate all these values. So how many of you knows about the binomial theorem?
I don't know, ma'am.
So how many of you knows the binomial theorem? Just raise your hand virtually. No one knows. If I want to compute x plus a to the power n, how I can calculate? If I have a value x plus a in a bracket and the power is n, how can I calculate it?
Ma'am, there is a formula for that.
Which formula? Can you tell me the formula?
I think we are using combination, permutation and combination formula here.
Yes, absolutely right. So that is a binomial theorem. If I want to add a plus b to the power n, then I have to use combination with some series. NC0 a to the power n and b to the power 0. Now I have to increase the b power and decrease the a power. A n minus 1, b1, b2, a n minus 2, b3, a n minus 3, and so on. When all the values are similar, NCN, a to the power n and b to the power n. So this is known as binomial theorem. So similar binomial theorem, we have to compute using dynamic programming. So here the value is, we are computing NCK. The n value may be anything and the k value will be anything. Maybe it is 1c1, maybe it is 3c1, maybe it is 5c2. So we have to compute, these values. Here the n value is 5 and the k value is 5. So we put k value here and n value here. 0 c0 is equals to 0c0 is equals to
1.
1c1 is equals to
1.
1.
Yes.
2c1 is 2c2 is equals to 1. 3c3 is equals to 1. So that's why we write all these values 1.
Okay.
Right? Or whenever we are writing 2c0, 3c0, 4c0, so at that case we always get 1. So we write 1 in this portion and 1 in this portion. Now we have to compute 2, 1, this value. N value is 2 and the k value is 1. This one we have to compute. Right? How we can compute it? Here is a formula. Ci comma j is equals to I minus 1, j minus 1 plus Ci minus 1 comma j. So here we have the I value 2 and j value is 1. So this is I minus 1 and j minus 1. This is I minus 1 and j. Yes, Himanshu. Himanshu, you raised your hand. Do you have any question?
No, ma'am. Sorry.
Okay. So here we have a value of C10. So this is 1 and this is 0. That is equals to 1. C11, here it is. So 1 plus 1 is 2. The value is 2. Now I have to compute 3, 1 when the value of n is 3 and the k value is 1. So what is the formula? Ci minus 1 and j minus 1. 3 minus 1 is 2 and 1 minus 1 is 0. This is I minus 1. That is 3 minus 1 is 2 and j as it is. So here it is j. So 1 plus 2 is 3. We got the value 3. Now I am computing 5, 2. Here it is. 5, 2 means I minus 1, that is 4. J minus 1, that is 1. I minus 1, 4 and j as it is, that is 2. Just put the values of these and get the 10 as a value. Any question, any doubt?
No, ma'am.
Okay. Deployed partial algorithm की if we are talking about, अगर हम इसकी बात करें, so this is again the shortest path problem. So we have 4 nodes. 1, 2, 3, 4. Again 1, 2, 3, 4. We will create the initial matrix D0 from the given values. When here is 1, 1, this is 0. If we want to go from 1 to 2, it gives a 9. 1 to 3, it gives a minus 4. I can't go directly from 1 to 4. That's why it is infinity. 2 to 1, it gives me a 6. 2 to 2, it gives me a 0. 2 to 3, I can't go directly because I can go 3 to 2, but 2 to 3, I can't go directly. I have to visit 1 and 4, then I can visit 3. So that's why here is infinity. 2 to 4, 2. Then again, 3 to 1 is not possible, infinity. 3 to 4, 5. 3 to 3, 0. 3 to 4, infinity. And similar with this. Any doubt?
No, ma'am.
So here we have to find D1 and D2. And all the other matrices so that I can get a value of each and every point. Right? Because हम लोग क्या करते थे Dijkstra algorithm में? We have to remove the infinity value and we have to find the shortest distance for that value. We have to perform the similar task here. So what you have to do, weight of the shortest path from one vertex to itself will always be 0 since we are dealing with no negative weight cycle. So we will put diagonal element as 0 in every iteration. So for the intermediate vertex j, we will put row and column element of dj as it is for dj minus 1. So for example, if I want to compute this infinity value, that means 2, 3. So what I have to do? This is 2, 3. I can go first on 1 and then go to a 3. Otherwise, I can pick 4 and go to the 3. So here, for creating D1, we have to find distance between every two vertex via vertex 1. Right? So here we have a vertex 1 between 2 and 3. So that means if we are talking about 2, 3, I can go 2 to 1 and then 1 to 3. Right? 2 to 3 is infinity. 2 to 1, if we are talking about 2 to 1, so here it is 2 to 1 is 6. Right? And then if I am going 2 to 1 with the 6 and going 1 to 3, so we will get 6 minus 4, that is 2. So which one is minimum from these two? 2. So 2 is the answer. Got the point?
Yes, ma'am.
Okay. Similarly, I have to compute the value for the 2, 4. Right? And we have a vertex. We have to do this via vertex 1. So we can say here is 2, 4, or I can go with the 1. 2, 1 or 1, 4. 2, 1 is equals to 6. And if we are talking about 2, 1, that is 6 plus 1, 4. 1 comma 4 is equals to infinity. So if we are adding infinity with some number that is greater than 2, so I need a minimum value. Minimum value is 2. Similarly, I have to do for the 3 comma 2. So this is 3 comma 2. Again via 1, that means D0 3 comma 2. So that means 3 comma 1 and 1 comma 2 we have to find. So smallest value is 5. Now similarly I compute D2. In that case we have to find the distance between every two vertex via 2. So if I am talking 1 comma 3, so what we have to find 1 comma 2 or 2 comma 3. Because here we have to calculate the distance via 2. So 1 comma 4, that means 1 comma 2 and 2 comma 4. 3 comma 1, that means 3 comma 2 or 2 comma 1. Add it and find which is the minimum value. So this is known as FWA. So you have to compute via 2, then you have to compute via 3, and you have to compute via 4 because you have 4 vertices here. In the last, you will get an answer in D4. Got the point? आप सब सो रहे हो?
No, ma'am, here.
No.
Present here.
You all? Okay. So that means you all are attentive in a class.
Yes, ma'am, sure.
So no questions and no doubts.
One question.
Now we have only one block, one remaining block. That sorry, one remaining unit. That is unit number 3. String matching algorithm. I'm giving you a 5 minutes. आप लोग फ्रेश हो जाइए. उसके बाद में स्टार्ट करती हूँ and I need acknowledgement in each and every question.
Okay, ma'am.
Okay, ma'am.
Okay, I'm giving you a 5 minutes break. Freshen up fast. Okay, let's start the class. Now for brute force algorithm. So here we have a string matching algorithm. To search for a location of a smaller text pattern in a paragraph or a book or any other source. The knife search algorithm compares the pattern string to the text, one character at a time. This process continues until there is mismatch of character between the pattern string and the text. So it's depending upon the requirement. So here is a pseudocode. If pattern string character is equals to text character, then compare next character of the pattern string. Shift the pattern string to the next character of the text. So here we have example. Here is text A, B, C, E, D, E, F, G, I. Here is a pattern string that is A, B, C. So maximum we have to shift for the 3. Similarly, in example 2, shift 4. We have A, B, C, D. Here is shift 0 because we found our pattern on the first case. In here, we have to find the pattern E, F, G. So it is shifted to 4th. After 4th place, we got the string, matching string. In example 3, maximum valid shift in the text is equals to length of the text minus my length of a pattern. So m into n is the complexity for the C. Now next is Kmp algorithm. In this algorithm, we have to calculate hash values. The first pattern string of m character and for the second m character substring of a text. If the hash value of 1 and 2 are equal, the algorithm will perform a brute force comparison between the pattern string and m character text substring. So the advantages of this algorithm is there is only one comparison per text substring and the brute force method is required only when hash values are equal. If the hash values does not match, the algorithm will pick up the next m character text substring for calculation of its hash value. So let's take one example. Here we have B, A, E, C, D, D, A, B, C, D, E, F. And the pattern is E, C, D. Right? Now we have to calculate the hash value. So where is E? E is E, C, D. So here we have a number of alphabet. For A, we have to use 1. For B, we have to use 2. For C, we have to use 3 and so on. Here for E, we have to use 5 to compute the hash value. So here is 5. 5 multiplied by 10 to the power 2. Right? So and for the next, this is 0, 1, and this is for 2. So now the next is C. C is 3. So 3 multiplied 10 to the power 1. And then 4 for D. 4 multiplied by 10 to the power 0. So 534 is the key value. So this is the first step. That means calculate the hash value of a pattern string. Now we have to take the second step, that is compute hash value of a text substring of the size equals to p. So for the first one, it is BAE. So the B value is 2 multiplied by 10 to the power 2 plus I multiplied by 10 to the power 1 and so on. Now, compare the hash value of P and T. We have to compare both value. Since both values are equal, pick up the next, because here when we compute the hash 534 and hash this, we got a value 534 and 213. Here is not equal. If the value are since both are not equal, pick up the next text substring. So next step, text substring, we have AEC. Right? So we have to find the hash value for AEC. AEC value is 153. Again, it's not matching. Now we have to pick the next. That is ECD. So ECD hatch function is 534. That is equal to the hash value of P. So when we compare each character of a pattern with each character of a substring, all characters are equal. The pattern string was found. So for this algorithm, you have to first find the hash value of a pattern string. How calculate pattern? So here is a pattern ECD. Right? You have to calculate the hash function for this pattern. How you can calculate? You got a value of each and every variable. 1 for A, 2 for B, C for 3, D 4 and E is 5. 5 multiply, you have to take a index. This is 0, 1 and 2. So this is n minus 1. So 10 to the power n minus 1, but that means 3 minus 1. And to the power 10 to the power n minus 2, 10 to the power n minus 3. And we have a values here for all the characters. Then we will get 5, 3, 4. Now you have to calculate first 3 character. If both the hash value is equal, then you found the match. Otherwise, take other 3. That means AEC. If the value is matched, that's okay. You found the substring. Otherwise, you have to calculate next 3 values and so on. Any doubt, any question you can ask. So cannot Maurice-Pratt algorithm. It's contained the complexity m plus n. This is a linear time string matching algorithm. So here m and n are the length of a pattern string and a text string. This happens because the KPS, the above algorithm, avoids frequent backtracking in the text string, as it is done in the naive algorithm. So the key idea for Kmp algorithm is to build LPS, that means largest prefix as suffix. So let's take one example. So in this, we first do the pattern matching exercise without building the LPS. So here we have a text and here is pattern. Examine the text and the pattern string. We notice that there is mismatch of character at the 4th position. On the 4th position, here is F and here is X. In the next string, it is F. Right? and in a pattern it is X. To decide from which position in the pattern string the search should restart, we go back and examine the substring in the pattern just before the position. Which position? Where there was a mismatch. We examine A, B, C substring of pattern. Since all the characters are unique, there is no prefix also as a suffix in this string. Therefore, we cannot skip any character. The comparison will start from the beginning always, beginning character of the string. That means A. With F its position, there was a mismatch. Again, there is a mismatch. So we will move to the next character. Right? And start comparing with the first character and so on. So here is LPS array. For example, we have a string like this, B, E, F, G, then D, E, F, and so on. So you will give the array pattern here. How many times the following pattern come? So if there is D in a pattern and there is D in the text, you will write 0 there. If there is E in the pattern but not in the text, you will write 1. How many times the following strings appear? We completed with our third unit also. How are you all?
Hi, ma'am.
Fine, ma'am.
Good. Okay. So again, I'm saying the similar thing. If you have any doubt related to any question, you can mail me on ritika@tctiltd.com. I will definitely revert on that mail. Right?
Okay, ma'am.
Give me a minute. I'm searching some question papers. MCS-211 is not uploaded. So I can give you an overview of a question paper that is already given in 2021 in MCA3 data analysis and design code. MCS-31, yes. So you will get these kind of question. So you always get a 3 hours 100-mark question paper. Question 1 is always compulsory for all, and you have to attempt any 3 from the other 4 questions. So the first one is write recursive binary search algorithm and analyzes its time complexity. That means you have to write the binary search algorithm, then you have to write the recursive equation for that algorithm, and after that you have to implement the runtime complexity. Define all the 3: best case, worst case, and average case. Solve the following chain matrix multiplication M1, N2, M3. So this is the question that we solved today. And this is very, very, very important question. You will get in your question paper definitely. And in a 10 mark. The next is integer multiplication. You will get these kind of equation and they will say kindly solve for the asymptotic notations. Write Prim's algorithm and define its complexity. So this draw all the spanning tree of the following weighted connected graph. This is compare time complexity of DFS and BFS algorithm for the given graph. Write DFS and BFS traversal sequence from node A. So you have to perform DFS and BFS here. This is not in your syllabus. Do you want to ask any question? You can ask. No question?
Ma'am, this is our last class, right?
Yes, this is your last class. This is a pre-poned class of 5th June. So I'm giving some topics for that is important for your exam point of view. If I am talking about the unit 1, basics of an algorithm and its property, you will get questions from a particular topic. Write down the topics. You will get a question from GCD using an Eclipse algorithm. Then you will get a question from the topic common running time. They will give you a series and ask to write in ascending order or a descending order. So there will be so many complexity value and you have to arrange in order. After that, mathematic induction. Now move to the unit number 2. Asymptotic bound. It's a request to you, kindly mute yourself. So you will get asymptotic questions from unit number 2. You will get numericals related to notations. And you have to calculate that particular equation using big O notation, theta notation, or you will get a question from you will get a question related to loops also. They will give you some code and say kindly compute the complexity. From unit number 3, polynomial evaluation algorithm is important. And here is a binary exponential, left to right and right to left both. Then linear search. You will get a question, explain the linear search with the time complexity, or you will get a question, kindly write the difference between linear search and binary search with complexity. Sorting, that means a bubble sort. Now, proceeding to the unit number 3. Sorry, unit number 4. Block 1, unit number 4. In this, you will get a question related to recurrence tree and master's method. Both are very, very, very important topic.
Recurrence tree and
Recurrence tree method and master's method.
master.
Next is block number 2, unit number 1. That is greedy technique. Huffman code is the important topic. Fractional knapsack problem is the important topic.
Pardon, ma'am?
What, ma'am?
Fractional knapsack problem.
Knapsack.
Yes.
Can you please repeat?
Fractional knapsack problem, Huffman code problem. Difference between local and global optima. Proceeding to the unit number 2.
Difference between
Local and global optima.
okay.
In unit number 2, binary search algorithm with complexity, merge sort and quick sort, stairs and matrix multiplication, integer multiplication.
Stairson's?
Stairs matrix multiplication. Integer multiplication. In unit number 3, adjacent matrix and adjacent list. DFS and BFS.
Pardon, ma'am?
DFS and BFS. Topological ordering. Move to the next block, that is block number 3, unit number 1. Kruskal and Prim's algorithm.
Kruskal and
Prim's algorithm. Ditch-Castro and Bellman-Ford algorithm.
Which one?
Ditch-Castro and Bellman-Ford algorithm. Maximum bipartite matching. Got it?
yes,
Yes, ma'am.
Yeah.
Unit number 2. So you will get a short note on principle of optimality. Yeah, I muted that person. Then matrix chain multiplication. Matrix chain multiplication is a very, very, very important question. Without this, your question paper is incomplete. So आप सोच लीजिए ये कितना important है. Then optimal binary search tree. Binomial coefficient computation. FWA. Floyd-Warshall algorithm. That is FWA. Now the last unit number 3. In unit number 3, you have 3 algorithms. Both are important. All 3 are important. Now you can ask any question if you have. Yes, it will be subjective type. Yes, this is your last class.
ma'am, how we will write the exam?
You will get an instruction before starting examination. Ria, you can ask your question. Ria, you can ask your question.
Ma'am, what does it mean by subjective type exam?
Subjective type means you have to write. There is no objective type.
Oh, okay.
So I'm assuming there is no any query, no any question. So this depends on scheduler. You can mail on query@pctltd.com if you required any other session. Or you have a group admin, Rahul or Praveen, Rahul sir or a Praveen sir. You can contact him. So I am winding up this session. All the best for your exam. If you have any doubt, any query, you can mail me. Thank you so much. Bye bye and take care.
Thank you so much.
Thank you, ma'am. Thank you very much.
Thank you.
Thank you.
Thank you, ma'am.